Hello, a Rosie math teacher coming at you from my second period grade 7 math class, where today we are working on lesson 9-1, measures of center and variation on textbook 209. Everybody going to the top right now, where we are talking about determining the appropriate measures of center and variation. I'm using hand gestures to remind you, when you are trying to find the number that is at the center of a row of numbers, let's say, for example, we were looking at a row of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Imagine that along my left arm, to you it would be left, is numbers 1, 2, 3, 4, 5. There's a number here in the center, and then there's 7, 8, 9, 10, 11. What number is in the center, class? 6. So what number would best represent the center of data that goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What number best represents the center of that data? 6. Do you understand how that makes sense? Physically, if you arrange those numbers in a single file line, what number would be in the center? 6. Now, sometimes, in this case, we would call that number 6 the median. It can also be called the mean. Let's talk about that for just a moment. I had my students write down this information just a moment ago. Guys, I need to grab my Apple Pen. It says your symmetric data contains no outliers. That means not a single number is far, 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 far away from all the other numbers. It also will use mean as your center amount, and it will use range as your difference between your lowest number and your highest number. So class, let's think about the range between 1 to 11. How do you find range? Subtract. 11, take away 1, equaling? 10. Excellent. So it would be 10 would be our range. So if I were writing down the information for what I would use for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, first of all, that would be symmetric because they're all occurring at about the same pace. Also, my center would be the middle number, and the median is always the number that's at the what of the line? The middle. Do you notice the similarity between the word middle and median? Okay? So the middle number is always the median. Also, the range is always the difference from lowest to what? Highest. All right, let's look at asymmetric data. Asymmetric data may contain outliers, so there might be a number that's way lower than all the other numbers. There might be a number that's way higher than all the other numbers. Say, for example, you had data about some students' grades on their most recent math test. Let's pretend, sadly, one student might have gotten a 12%. And imagine if the entire rest of the class scored 70% or higher. Do you agree that the 12% kid is an outlier? They lie outside the norm of the rest of the class. So an outlier is one that is either far lower or far higher. So asymmetric data may contain an outlier. It will also be known to use median as the center. So in other words, when you write all the data values, remember our example of 1 through 11, it's the number that would land in the what? Middle. So think median, middle. And IQR, which is an interquartile range. Now, I have an example for this, prepared ahead of time with all my worldly goods here. 4 quarters. Okay, when you are representing the first 25% of data, you call that the first quartile. Do you see the similarity with the word quarter and quartile? Because it represents 1/4 of your data. When you represent the second fourth of your data, it is the second quartile. The beginning of the second quartile is also the beginning of the IQR, the interquartile range. And then your third quarter would be your third quartile. The end of the third quarter represents the end of your IQR or the interquartile change. The end is the fourth quarter. Everybody knows that, right? In a football game. The end is your what? Fourth quarter. Okay, so if your data is represented by 4 quarters, if we are using range to show the amount of variation by how much the numbers vary, then you're going to go from the beginning of the first quarter to the end of the fourth quarter. But if you are using IQR, the interquartile range, then set aside the first quarter, set aside the last quarter, and only use the range from beginning of second quarter to ending of third quarter. That is your IQR. You'll understand more as we get to practice this. All right, so let's go to item number 1. The line plot shows the ages of participants in the middle school play. Now first, just visually, class, look at this chart. Do you notice whether it is symmetrical or not symmetrical? And let's talk about symmetrical. Symmetrical means that if I split something right down the middle, the left side will basically match the right side. Like butterfly wings are considered symmetrical. So on the count of 3, say symmetrical or not symmetrical for this item. 1, 2, 3. Symmetrical. If you said symmetrical, you are correct. Watch. Draw a line right down through those dots. Do you agree that as you split those dots down the middle, you would have a left side that is a reflection of the right side? Therefore, you should call it what? A symmetric arrangement, symmetric data. So, for example, they're asking you to give them the measures of center and variation. So please write center. And then because this is symmetric data, the one we wrote in black ink, what will you use to showcase the center? Will you use the mean or the median? Uses what? Mean. Okay? So first of all, we're going to say center, and we're going to say that we will use the mean. Now I'm going to show you how to find the mean, but we're not going to work on it right this moment to save time. I just need you to understand how to find it. I have 2 ways to help you remember mean. One of them is, it stands for me averaging numbers. Have you ever learned about how to average numbers? To find the average. If you play sport, you probably know how to find an average, don't you? Okay, here's what I sing to you guys. Because of course, I have a little bit of a song to go with almost everything. If you're asked to find the mean, also known as average, add them up and then divide. Add up all the numbers and divide by number of numbers to be sure you will get it right. So let's look at your numbers. Over here, the age of the kids in the middle school play. How many kids were age 11, class? 3. So in your calculators later, you're going to do this. Write this down now to remind yourself. 3 times 11, inside of parentheses, plus, and then how many kids were age 12? The dots represent children. I'm hoping that very soon, more than just that one student will be able to count dots and tell me. All right, so 3 times 12. And then how many students are age 13? 4, excellent. I'm getting more, thank you. Plus 3 times 4 plus how many students are age 14? 3, awesome. 3 times 14 plus, what is the last thing I shall write? 3 times what? What's the last age? 15. So in a moment, not right this second, in a moment you will enter in your calculators. Do you understand that each of those dots represents an 11-year-old child? And that you are responsible to add up all these ages, so the number of years old they are. Don't you agree, instead of doing 11 plus 11 plus 11 plus 12 plus 12 plus 12 plus 30 plus, let's stop already, right? Don't you agree you would rather do 3 times 11 plus 3 times 12 plus 4 times 13? Did I write that wrong? Yeah. Yes, I did. I wrote 3 times 4 instead of 4 times 13. That is what I need to fix right now. Thank you so much. Glad we're checking this. 4 times 13. Okay? Plus 3 times 14 plus 3 times 15. Wave if you are understanding why you need to add it all up this way. It's much faster this way. Okay? Add up all the numbers and divide by number of numbers to be sure you will get it right. What can I count in my graph to know how many numbers I was working with? Count up all the what on this chart? All the dots. Excellent. Guys, if I count by 3s for these 4 sections, what can I write multiplication that would represent 4 columns with 3 in each column? I would write 3 times 4, and then I would add my center column. How many dots in my center column? 4. I'm confident you guys can do this mentally. What is 3 times 4? Plus 4. So in the end, whatever total you get, you will then divide that total by what? What's the number of numbers? 16. Please write yourself a note so later you will know how to find your mean. Now we also need to find our variation. I'm going to erase a little bit to give myself room to teach you about variation. Now variation has a root word called vary, and I don't mean V-E-R-Y, I mean V-A-R-Y, meaning it changes. It is somehow different. In the variation for symmetric data, what kind of variation did we already say we're going to use? Say it, class. Range. So we are going to use the range of taking our lowest value and subtracting it from the highest value. What is the highest age here? It is 15. What is the lowest age here?
11.
It is 11. So guys, we can solve this mentally. What is 15 take away 11? Okay, so you can go ahead and write your range value of what? Say it again. 4. If you're asked to find the range, simply subtract the lowest from the highest, and you will get the range. Later, you're going to find the mean based on how I already showed you. All right, let's go on to item number 2. The stem and leaf plot shows the scores from a recent math vocabulary quiz. Guys, above the word stem, I want you to write tens place. Write the word tens. Above the word leaf, I want you to write ones. Excuse me. So if I grab the stem 7 and write it down over here, and I set it next to its first leaf 0, what number do I create? 70. Do you follow how to use a stem and leaf plot? What would be the second number I would create? I've used up the leaf 0, but have I used the leaf 5? No. Please at least write down these two numbers. The next number will start with a what? 7, end with a what? Read the number. 75. Let's skip down to the tens place, having the number 10. So I would write the 10, or the stem, 10. What would the first leaf give me? It would give me another 0, so my number would be 100. Every time a leaf appears again, it means another of that number. So 100, 100, 100, 100, 100. Do you get there are lots of values of 100? Okay, when you look at the scenario, you'll see why. The stem and leaf plot shows the scores from a recent math vocabulary quiz. So guys, what was the most common score the kids in that class received? 100. Excellent. Do we see anything that's an outlier? Like one single score that's way lower or way higher? Yes or no? No, we don't see any outliers, do we? Okay, so it doesn't contain any outliers, but hold on. Does it have to contain outliers in order to be asymmetric? No, it doesn't have to, but it may. Okay, so we just look at that to see if it blocks one of them out or not. So we don't have to worry about outliers, but we do need to ask ourselves, and you can set that right there. We do need to ask ourselves if it's symmetric or asymmetric. Now notice, if I split in half right here, do I have a mirror image on this side as I do on this side? No. So what is it? Is it symmetric or asymmetric? It is asymmetric data. It may contain outliers, but it doesn't have to, and this one does not. But what will we use for the center of asymmetric data? Say the word, median. What will we use for range of asymmetric data? IQR. Again, we're going to talk about that. Okay, so for median, guys, I'm not going to make you write all these numbers out, but I am going to teach you how to use your stem and leaf plot to do a little thing I call high-low. Are you ready? We need to find our middle or median number. It's always the number that if we wrote out all the numbers, it would land in the middle. It would be the center. So to find the median, we have to cross out a lowest number and a highest, but we're going to go high-low. So let's cross out a highest amount first. Guys, do not cross out the stem until we're all done with it, right? So I'm going to start right here. That represents my highest. I know there's a lot of the highest score because it's duplicated, but we've got to cross it out every time. So ready? Everybody cross out this 0 and say high. We just crossed out a high number. Now go to the stem 7 and cross out the lowest number. So we just crossed out 100 on the high end, 70 on the low end. Are you following what we're doing? Okay, please do this with me. You don't have to go super slow. Ready, go. Cross out high, cross out low. Cross out high, cross out low. Okay, we're done with that stem. Cross out high, cross out low. Okay, we're done with that stem. Cross out high, cross out low. Are you with me? Are you keeping up? Keep drawing them. Cross out high, cross out low. 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 Now I know these are all the same, but just humor me. Cross out high, low, high, low. What is our middle number? And don't say 0 because we've got the stem 10 that we need to put in front of it. What is our median? 100. So guys, for this answer, please write C for center, and then am I writing mean or median? Median. I just had to find my middle number. And then for my median, what did that equal? 100. Excellent. Do I have any questions on how I got a median of 100? And why did I go with median instead of mean? Because my data was not symmetric. If it is not symmetric, it is asymmetric. If it is asymmetric, I use median for my center. And then for my variation, I will use what? Instead of range, I will use IQR. So let me show you this. For IQR, you now need to find the median of all the numbers that came before your actual median and the median of all the numbers that came after your actual median. And use those two amounts for your IQR. So now I hope you just did a slash on the first amount, and now you're going to create an X as you do high, low, below 100. So watch first so you understand what I'm doing. High, low of the first 50% of my data. Are you seeing what I'm doing? Okay. I'm trying to find the split point of the first 25%, the first quartile, and the second 25%, the second quartile. Because my median lies exactly between my, I almost lost my money, between my second and third quartile. Okay, so find the median on either side of the median. Okay, here we go. So high, low, high, low, high, low, high, low, high, low. Ooh, what is the ending / beginning of my second quartile?
0.
Well, put the 9 in front of it. 90. So for your work section, you want to say going from 90 up to, now let's find our upper number, the median of our upper 50%. So class, everything before this median is our first 50% of data. Everything leading up to 90 is our first 25% of data. Everything between 90 and 100 is our second quartile. Are you seeing the relationship here? Everything after this median is the upper half of our data, so the upper 50%. Now we need to find the median in the upper 50%. So again, we're going to start with high, low, high, low. What do we already know it's going to be?
100.
Yes, because we only have hundreds left. So I give you permission to say 90 to 100, meaning that your IQR is equal to what?
90 to 100.
Is also, it's 90 to 100. Remember that to find the range or the IQR, we have to take the lower and the higher and subtract. What is 100 minus 90? 10. So your IQR will actually be 10 because it's the interquartile range. It's the amount from the second quartile to the end, the beginning of the second quartile to the end of the third quartile. Do you see how those are the inner quarters? The inter. So that's how you're getting the interquartile range. All right, let's go to item number 3 for tonight's homework. The box plot shows the number of customers for 2 weeks at a local shop. Class, circle that asterisk. That is one tiny piece of data that is really far away from all the other data. So is this an outlier, yes or no? Yes, that is an outlier because it's far, far away from all the other data. Which one says contains no outliers, symmetric or asymmetric? Asymmetric says may contain outliers. Which one says cannot have outliers? Symmetric. So is this data symmetric or asymmetric? We already know it's asymmetric. So go ahead and write asym, or however you want to abbreviate, asymmetric. Now what you're looking at is called, have you guys heard of box and whisker plots before? Okay, so let me teach this quickly. The center dot, do you all agree there's a beginning dot, an ending dot, a center dot, and my blue dots will be beginning of the IQR, ending of the IQR. Imagine a quarter in between each of these. So your first 25% of data occurs right here. Your second 25% of data occurs here. Your third 25% of data occurs here. And your fourth 25% of data occurs here. So the first one is your first what? Quartile. The second one is your second quartile, third quartile, fourth quartile. Are you understanding those terms? Okay, so remember, for this one, for your center, because it is asymmetric, what are we going to use for the center? Median. You're in luck. When they give you a box plot, the median is always the what dot? The middle dot. What does the middle dot appear to line up with? It's halfway between 240 and 260, so what is it? 250. I hear a few people saying that correctly. Excellent job. So go ahead and write for yourself that your median for item number 3 will equal 250. And then ask yourself, what will I use for the variation? Will I use range or IQR? Well, remember we said this was asymmetric, and according to our notes, we're going to use median and what? IQR. So I'm going to use IQR. Now, I don't write IQR as my answer. IQR is part of my answer, but I need to find the value. So where does the IQR begin on my box plot? It begins at the beginning of the second quartile. First quartile, second quartile. What amount does that appear to line up with? Say it. 190. Excellent. So write that amount down. And then do you think I want to use the median or the end of the third quartile? End of the third quartile. What does that appear to line up with? 300. So in a moment, what will you do on your calculator to find the interquartile range? Excellent. And don't anybody say it. I don't want anybody getting free answers. Are you understanding how to at least get started on these items? All right. I want you to begin now. Thank you. I hope this helps.